with photosynthesis in plants. Photosynthesis involves capturing, conserving and converting solar electromagnetic radiations into chemical energy like glucose, which would be stored as starch in plants. Okay, so glucose will be more in the plants, they would be circulated as sucrose. They are not circulated as glucose, they are circulated as sucrose. So the photosynthesis takes place in presence of chlorophyll pigments. Okay, so they are going to absorb the solar electromagnetic radiation. They capture, conserve and convert solar electromagnetic radiation into chemical energy, which is nothing but glucose, and they are carried in the plants as sucrose. Okay, you have already studied about translocation of organic solutes. So that is done during the photosynthesis process. The raw materials for photosynthesis are carbon dioxide and water. Carbon dioxide and water combine together to form glucose. Oxygen is liberated. One of the important steps, byproducts of photosynthesis is liberation of oxygen. Oxygen cycling that takes place in nature started to happen because of this photosynthesis process. Early primitive world, they did not have oxygen. You know about that. That was a reduced atmosphere, which we have also studied in Miller's apparatus. Okay, we never included oxygen in Miller's apparatus. So you should understand, plants are responsible for liberation of oxygen during photosynthesis process. Okay. So it is a physical as well as a chemical process, physico-chemical process which uses light energy to synthesize organic compounds like sugar. Okay. Primary source of food is by photosynthesis and release of oxygen to atmosphere. Formation of food and release of oxygen to atmosphere is an important function of photosynthesis. Okay, so you can see that from the sun, the light falls onto the leaves. They have these pigments, chlorophyll A, chlorophyll B. Okay, these pigments, they are going to trap light and they are utilized for formation of food. Solar electromagnetic energy is, radiation is a source of energy. Carbon dioxide and water, if you try to combine in lab, they form soda. Carbonated water is nothing but soda, isn't it? But in nature, leaves are going to form this by complex process like light reaction and dark reaction. They undergo to produce what we call it as a food. They are the producers. Without these plants, we cannot survive. I have already told you, leaves are the kitchen of the plant. They are the genuine Annapurneshwari. Ultrastructure of chloroplast is Annapurneshwari. Because they are going to trap the solar electromagnetic radiation, convert them into chemical energy, that is glucose. None of this process is possible in our labs. Naturally, it is happening in plants. There are huge number of enzymes involved. We'll study that in detail later on. So the carbon dioxide is taken, water is taken as a raw material and they are utilized for the formation of food. Oxygen is liberated, the food synthesized is stored as starch. The historical role you have to understand before the discovery of photosynthesis. Joseph Priestley was the person who discovered oxygen by his bell jar experiment. He showed that the respiratory air or breathing air is liberated by plants. Whenever plants were placed in this bell jar, the rat was able to survive for longer duration of time because the plants liberated oxygen, which was required for our survival as well as the rat's survival. So the discovery of oxygen was by Joseph Priestley. Okay. Then Angel House, aquatic plants, he did an experiment to show light and dark, what are the reactions that they are going to take place. Light is required for photosynthesis to take place. That was revealed by John Angel House. Green parts of plants are involved in making glucose and they store as starch. This was revealed by Julian von Sox. Okay, this is the historical steps before we came to know about this details. Many scientists have worked and shown this photosynthesis steps. Then Engelmann split light using prism into 7 colors with chaos. Of these 7 colors, a few of them are observed. Green algae, Cladophora, they are going to detect the site of oxygen evolution was done by Engelmann. Then Neil, he did experiment with purple and green bacteria and demonstrated photosynthesis is dependent on light. It is a light dependent process. Okay, and they are obtaining oxygen from water. What is the source of oxygen? From water. There is a breaking up of water during photosynthesis. We call it as photolysis of water. Water breaks down to liberate hydrogen and oxygen. Okay, oxygen is not coming from carbon dioxide. Oxygen is coming from water. That was proved by Van Dien. Okay, the overall reaction, 6 carbon dioxide plus 12 H2O, they are going to form C6H12O6 plus 6 water molecules, 6 oxygen is liberated. This is the overall reaction of photosynthesis. Now chloroplasts, what you have to remember is they are double membrane cell organelles. They have units in them, coin-like structures, which we call it as the thylakoids. Thylakoids are arranged one above the other, and they form a pile of coin-like structures, which we call it as granum. The thylakoids are interconnected, and we call them as lamellae or thread. Stroma, lamellae or thread. If you look into this diagram, this space, we call it as stroma. Double membrane is there. Outermost membrane of chloroplast, innermost membrane. The space it is filled with stroma. Okay. Now the thylakoids are arranged like coin-like structures. Each thylakoid will be having photosystem 1, photosystem 2, which we'll discuss later. Then these thylakoids are interconnected by bridge-like structures called as thread or stroma lamella, or it can also call them as stroma thylakoids. Okay. Thread or stroma lamella. They are connecting this pile of granum. Granum is having thylakoids arranged one above the other. So this stroma is the place where there are reactions that are taking place in the dark reaction, especially the Kelvin-Kelvin cycle. Okay, they take place in this stroma. So ultrastructure of chloroplast, green leaves, green stem, and floral parts, sepals, they have chloroplast. Okay, chloroplast is found in mesophyll cells of leaves. Mesophyll cells are of 2 types in leaves, dicot leaves. What are they? Palisade chlorenchyma, spongy chlorenchyma. We have discussed already there. In chloroplast, the membrane system is responsible for trapping the light energy and also for the synthesis of ATP and NADP. ADP is energy molecule. Energy currency of the cell is ATP, whether it is in human beings or in plants. Adenosine triphosphate. NADPH2 is also food molecule. 1 NADPH2 is equal to 3 ATPs. It is an energy-rich molecule, we call it as NADPH2. Okay, so they are all formed in the chloroplast. Oxygen is liberated in the chloroplast during non-cyclic photophosphorylation. So these are all the steps that are involved in the chloroplast. The ultrastructure of chloroplast you have to remember about. The pigments that are there in chloroplast. Chlorophyll pigments, which is the reason for the green color of the leaves. Chlorophyll A, chlorophyll B. They also have xanthophylls and they also have carotenoids. Carotenoids are orangish in color. Xanthophylls are yellow pigments. Okay, paper chromatography, if you have done in your map, separation of this BAXC, chlorophyll B, chlorophyll A, xanthophylls, carotenoids would have taken up. If you have done that Wattmann's paper using that separation of chlorophyll pigments. Okay, so these are all the pigments that are found in the chloroplast. We'll discuss about all this in the next class.